Imagine a world where energy is clean, abundant, and virtually limitless. That's the promise of nuclear fusion, and France just took a giant leap toward making it a reality. In a groundbreaking achievement, France's West Tokamak kept a fusion reactor running for over 22 minutes, shattering the previous world record and igniting hope for a sustainable energy future. But here's where it gets controversial. While this milestone is undeniably impressive, it's just one piece of the complex fusion puzzle. Can we truly harness this power on a global scale? Let's dive in. On December 14, 2023, the West Tungsten Environment in Steady-State Tokamak Reactor in France held a hot plasma for 1,337 seconds, a little over 22 minutes. This isn't just a number, it's a game changer. Long, stable plasma operation is critical for future fusion power plants, and West's achievement demonstrates that researchers can maintain extreme conditions without damaging the reactor's internal components. This surpasses the record set just weeks earlier by China's East Reactor by about 25%, proving that the race to fusion is heating up, literally. But this is the part most people miss. Inside West, physicists used powerful magnetic fields to control a superheated gas of charged particles known as plasma. The real challenge? Keeping everything stable. Plasma is unforgiving. Even tiny mistakes or instabilities can spiral out of control if not managed instantly. Anne-Isabelle Etiembre, Director of Fundamental Research at the Commissariat à l'Énergie Atomique et aux Énergies Alternatives, CEA, hailed this as a key technological milestone, achieved by injecting 2 megawatts of heating power to sustain the reaction. So what exactly is a tokamak? Picture a donut-shaped magnetic bottle. Its magnetic fields guide charged particles in a circular path, preventing them from crashing into the walls, a process called magnetic confinement. This allows scientists to heat the plasma to temperatures hot enough for atomic nuclei to fuse, releasing energy in the process. France's next step is the ITER project, a larger device currently under assembly, designed to produce 500 megawatts of fusion power from just 50 megawatts of input. Here's where opinions start to clash. While long pulses like West's 22-minute run are crucial, they're only part of the equation. Energy output is another critical factor. For instance, the UK's JET facility produced a record-breaking 69 megajoules of fusion energy in just 5 seconds, a burst of power that dwarfs West's output. So, which approach is better? Stability over time or high-energy bursts? The truth is both are necessary. Different reactors push different boundaries, collectively mapping out what a future fusion plant must achieve. Why does this matter? A commercial fusion power plant needs to operate continuously for long periods while maintaining stability. That means managing temperatures, fuel purity, and material durability. For example, tungsten, used in West's diverter region, can withstand extreme heat but requires precise handling to avoid damage. And let's not forget exhaust management. The plasma must release heat and particles in a controlled manner to protect the reactor's components. Here's the reality check. A 22-minute plasma run doesn't mean we're generating net electricity. West is a research device focused on stability, not energy production. Achieving net energy gain depends on a delicate balance of factors like plasma density, temperature, and confinement efficiency. It's not as simple as turning up a dial. Looking ahead, the CEA team plans to extend plasma operation to hours while gradually increasing power, refining the playbook for safe, repeatable fusion. Data from West will directly inform ITER's operation, bridging the gap between lab experiments and real-world applications. And while fusion doesn't produce long-lived radioactive waste like fission, it does create activated components that require careful handling. This is why material choice and design are so critical. So here's the big question. Can fusion truly power the world? Despite the challenges, West's progress is undeniable. Each record brings us closer to reactors that could provide safe, reliable, and virtually limitless energy. But what do you think? Is fusion the answer to our energy crisis, or are we chasing a dream? Let us know in the comments below. If you found this fascinating, subscribe to our newsletter for more groundbreaking stories. And don't forget to check out EarthSnap, our free app for daily wonders from around the globe.